This is homework 3, question 1. The question 1 asks about let the probability of x equal to k equal to b times k times p to the power of k minus 1, and k is equal to 1 to infinity, and the probability is within 0 to 1. So the subproblem A asks about find b so that p, the probability of x equals to k, represents a probability mass function. So b times k times p to the power of k minus 1 can be rewritten as sum of k equals to 1 to infinity bk p to the power of k minus 1, and assume the sum of k equal to 0 to infinity p to the power of k get differentiate with delta p and can get sum of k equals to 0 to infinity k times p minus k minus 1, and also that the sum of k equal to 0 to infinity p to the power of k is equal to 1 plus p squared plus to infinity, and we can rewritten as 1 divided by 1 minus p. So the differentiation is also differentiate this side. So we get 1 divided by 1 minus p to the power of 2. So sum of, and then we rewritten this k minus 1, so times p again. So this side can get p divided by 1 minus p to the power of 2. So when k goes to infinity, the sum of k equals to 0 to infinity, this product is similar to the sum of k is equal to 1 to infinity k times p to the power of k minus 1, and this is equal to 1 divided by 1 minus p to the power of 2. So this bkp to the power of k minus 1 is equal to 1. So we can get b is equal to 1 minus p to the power of 2. And for subproblem B, we need to find the mean of x. The mean of x by the equation, we can get the mean of x is equal to sum of xi pi, and pi is equal to the probability of x equal to xi, and we can write as this equation. The sum of k is equal to 0 to infinity times k times p, the probability of x equal to k, and we can use the formal equation, this one. So is equal to b to the k squared p to the k minus 1. So also again differentiate this equation. We can get the sum of k equals to 1 to infinity k squared p to the power of k minus 1 is equal to 1 plus p divided by 1 minus p to the power of 3. And this one, because this b, we can times 1 minus p to the power of 2. So finally we'll get 1 plus p divided by 1 minus p. And for e to the x squared, it's just a similar process. It's just the sum of xi squared pi, and we get bk to the power of 3 p k minus 1. So differentiate this product, we can get k k to the power of 3 p k minus 1 is equal to this, and I mean this, we can use the equation here. So differentiate of this equation. So we got 1 plus 4p plus p squared times 1 minus p to the power of 2 divided by 1 minus p to the power of 6. So by rewritten this, we get 1 plus 4p plus p to the power of square divided by 1 minus p to the power of 4. And also this e to e square x square is equal to b times this product. So b is 1 minus p to the power of 2. So finally we got 1 plus 4p plus p squared divided by 1 minus p to the power of 2. And for problem D, we need to find the mean of x squared minus mean of x squared. So we calculate it in subproblem B and C. So mean of x squared is 1 plus 4p plus p of square divided by 1 minus p square, and mean of x is equal to 1 plus p divided by 1 minus p. So square of it, we can get 1 plus 2p plus p square divided by 1 minus 2p plus p square. So mean of x squared minus mean square of x is this, and we can get 2p divided by 1 minus p square is equal to 2p divided by 1 minus 2p plus p square. For subproblem E, so let probability is equal to 1/3, find the conditional probability mass function. So P, the probability of x equals to k given x larger or equal to 2 and smaller or equal to 5. So when b is equal to 1 minus p square, we can get it is 4 divided by 9, and the probability of x equals to k given x in the range of 2 to 5 is equal to x equals to k, and x in the range of 2 to 5 divided by the probability of x equals to k, which k is equal to 2 to 5. And because this is conditional probability, and this part can be written as this part. So this part can be written as 4 divided by 9 times k times 1/3 k minus 1. K is from 2 to 5, and we get around this. And this one can be rewritten as this part here, and k is equal to 2, 3, 4, 5, and others is equal to 0. And this is question 1.